February 17, 1943, Sidi Bouzid, Tunisia. The desert lay silent after days of fire. Columns of black smoke rose above the dunes where tanks had burned out in the fierce battles between the Afrika Korps and the American 1st Armored Division. On the edge of a captured field, German engineers stood around an unfamiliar shape half buried in dust. It was an American M4A1 Sherman, its olive paint still glinting faintly under the sun, the white star of its origin now crossed over with a hastily painted black Bokenkreuz. To the German soldiers it was an odd trophy, a machine they had underestimated since the first reports from North Africa called it crude, heavy, and unimaginative. But as the engine roared to life under their hands, that perception began to change. The tank rolled forward through the sand, steady and obedient, as if oblivious to the war raging around it. Its captors noted every movement, every sound, every smooth gear change that contradicted the expectations of men raised to believe that precision equaled superiority. This vehicle, sturdy, loud, and uncomplicated, would travel farther than any of them could imagine. It would outlast the battles that birthed it and expose a truth that no amount of German craftsmanship could deny. That reliability, not complexity, defined victory. Over the next 4.5 days, a small convoy of German reconnaissance vehicles escorted the captured tank north across 300 kilometers of hostile terrain. The desert punished all who crossed it. Its heat, its dust, its endless vibration turned gears to powder and bearings to molten metal. Yet this American tank never faltered. Its engine did not overheat. Its transmission shifted cleanly. Its tracks bit into sand and gravel alike with a confidence that defied logic. The officers traveling with it kept meticulous notes, their curiosity slowly giving way to unease. Every kilometer challenged their assumptions about what industrial America was capable of building. When the convoy finally reached the port of Sfax, the Sherman still ran as if new. German mechanics wiped dust from its hull and stared at the name painted beneath the grime, War Daddy 2. For them it was a trophy of war. For the engineers who awaited it in Germany, it was an omen. Orders came swiftly from Berlin. The vehicle was to be shipped intact to the Kummersdorf proving grounds near Berlin. It was to be examined, dissected, and tested to the limits of science. The intent was simple: to understand how a supposedly unsophisticated enemy could produce a machine that refused to die. Days later, as the cargo ship carrying the Sherman cut across the cold waters of the Mediterranean, messages flashed through German military channels announcing the arrival of a valuable specimen. Technicians at Kummersdorf prepared their tools. Measuring instruments were calibrated, test tracks cleared, and engineers from armament offices assembled in anticipation. None of them knew that what awaited them would unravel long-held beliefs about German technical supremacy. In early March, at a railway siding south of Berlin, the tank arrived under gray skies. Workers craned it down from the flat car and rolled it onto the proving ground's coarse gravel roads. The name War Daddy 2 still faintly marked its hull, the American star visible beneath layers of new paint. German stencils soon covered it, notations of armor thickness, angles, and serial numbers. It was given a temporary registration code and entered into the logbook as a foreign vehicle under evaluation. For the engineers who surrounded it with clipboards and cameras, it was another assignment. For history, it was the beginning of a revelation. The Kummersdorf facility, a vast complex of hangars, workshops, and firing ranges, served as the beating heart of German weapons testing. Here, the most advanced technologies of the Reich were born, and here too came the relics of enemy ingenuity captured on the battlefield. The American tank was unlike the others. Its weld seams were clean but unpretentious, its components sturdy yet simple. When the first inspection began, the German engineers approached it with professional detachment. But as they examined the powertrain, their curiosity grew sharper. They removed the transmission cover and found a pattern of gears they did not expect. Herringbone teeth, designed to distribute loads smoothly and minimize wear. To them, this was an old idea discarded decades earlier as impractical for mass production. Yet here it was, not handmade in a laboratory, but stamped out by the thousands in American factories. The engineers measured tolerances and found them wide by German standards, sloppy even. And yet every part fit perfectly, every surface performed its function. It was engineering that valued purpose over prestige. By late spring, the tests had begun in earnest. Mechanics filled the fuel tanks, checked the oil, and rolled the Sherman onto the first course of rough ground. The The narrator's calm tone carries the weight of realization, the moment when comparison became confession. The tank moved forward with the easy rhythm of a well-balanced machine. Its engine, a Continental radial adapted from aircraft use, ran with a steady hum, indifferent to changes in terrain. The driver's compartment, roomy and logical, reflected a philosophy foreign to German design. This was not a machine for the elite. It was a tool built for soldiers who had learned to drive trucks and tractors back home. German test logs recorded their findings with clinical precision. Fuel consumption acceptable. Gear synchronization excellent. Transmission shifts smooth under load. No overheating observed. Where German tanks required careful double clutching and constant mechanical sympathy, this foreign machine demanded almost none. It tolerated errors, absorbed abuse, and kept moving. Within weeks, the engineers began to realize what they were seeing was not luck or isolated craftsmanship. It was the outcome of an industrial culture utterly different from their own. America's automotive industry had spent decades building machines for millions of citizens. Germany's had built them for connoisseurs. The difference showed in every bolt and bearing. As the trials continued, so did the disquiet. In workshops across the proving ground, conversations grew hushed. Some engineers admired the Sherman's simplicity, others dismissed it as primitive, but all recognized that it had achieved something Germany's precision could not: dependability in the field. Reports were drafted in cautious language. Phrases like operational reliability exceeds expectations and design demonstrates remarkable tolerance. Those words concealed a growing anxiety. By early June, the tank had become a silent challenger to German pride. Its endurance astonished every observer. Test runs stretched for days without incident. Maintenance checks revealed minimal wear. The final drives, expected to show metal fatigue, remained intact. The lubrication systems worked efficiently without complex filters or auxiliary pumps. Even the air cleaner, a simple oil bath design, kept desert dust from choking the engine. In a war where every advantage mattered, this was more than curiosity, it was warning. A weapon that never broke could outfight one that did, no matter how advanced the latter might seem on paper. At Kummersdorf, surrounded by walls built to keep secrets, German engineers were beginning to confront a truth their ideology had long denied. In Berlin, preparations began for a major armament demonstration. The ministry wanted to showcase the Reich's newest armored creations, the Panther, the Ferdinand, and other test vehicles fresh from the factories. Among the lineup, almost as an afterthought, was the captured American tank. It was to serve as a comparison piece, a curiosity from across the ocean. Yet as the event approached, many at Kummersdorf understood that the real comparison might cut deeper than anyone wished to admit. Through the spring rains of 1943, War Daddy 2 continued to run, its pistons pounding steadily beneath the steel shell that had once borne an American crew. Each mile added to its legend inside the proving grounds. Every time it started without protest, another layer of denial eroded among those who studied it. The German engineers who had been taught to worship precision were learning that in war, perfection was not a virtue if it came at the cost of endurance. The section closes as summer approaches. The Sherman waits on a transport truck bound for the next stage of testing. Around it, the mechanics tidy their tools, the officers gather reports, and the hum of engines fades into the evening. No one speaks aloud what they all suspect, that this captured tank has already passed every test that truly mattered. In the quiet of Kummersdorf, the machine rests beneath the darkening sky, its metal still warm, its lessons still unfolding. June 6, 1943, Hillersleben Artillery Proving Ground, Germany. The summer air hung heavy with oil fumes and anticipation. Across a long slope of packed earth, 3 machines waited under gray clouds. A Panther tank, gleaming and new, a massive Ferdinand tank destroyer, and the captured American Sherman, its foreign lines softened by a coat of German paint. Senior officers and armament officials gathered along the ridge, their boots sinking into damp soil as they raised binoculars. Among them stood Reich Minister Albert Speer, responsible for production and efficiency, his eyes fixed on the hill. The demonstration was to confirm the superiority of German design. It would instead reveal something no one was prepared to acknowledge. Engines rumbled to life. The Sherman moved first, its radial engine throbbing in a steady rhythm. As it climbed, the sound was unhurried, confident. Each gear changed smooth, each movement precise. The tank reached the top without struggle, paused. then descended gracefully as observers scribbled notes. No smoke, no hesitation, no failure. When it came to a stop, mechanics checked temperatures and pressures. All remained within tolerance. The audience murmured quietly. Next came the Panther. Sleek, angular, and imposing, it embodied German ambition. Power through complexity. Its 700 horsepower Maybach engine roared as it began the ascent, clawing the hill with brute strength. But the climb was labored, the transmission whining under stress. Midway up, the driver hesitated, shifting too soon. The tank jerked violently before recovering. At the summit, the clutch emitted a sharp, acrid smell. It had performed, but not gracefully. The Ferdinand followed last, immense and overburdened by its electric transmission system. Halfway up, its motors faltered. The giant stalled, smoke spilling from its rear. Technicians ran forward as the crowd shifted uneasily. Speer said little. He simply turned to his aides and watched the recovery crew struggle to restart the Ferdinand. Around him, the men responsible for Germany's armored doctrine stood in silence. Their most advanced machines had shown their fragility before their own creators. The foreign tank, built by men they dismissed as industrial amateurs, had embarrassed them by doing the simplest thing imaginable. It had worked. The next morning, at the armament conference held nearby, Speer reviewed reports with his technical advisors. The data was irrefutable. The Sherman's transmission, simple and synchronized, required almost no maintenance. Its engine, though less powerful than the Panther's, delivered steadier performance over time. Its suspension distributed weight evenly across terrain, reducing stress on the drivetrain. When journalists later published an article describing the American tank as a praiseworthy product of North American industry, it was intended as propaganda to soothe public nerves. But within the engineering offices, the truth spread quietly. At Kummersdorf, the testing continued in secret. Every system of the Sherman was measured, logged, and compared against German equivalents. When engineers plotted the data on charts, the differences were undeniable. Operational endurance exceeded 2,000 kilometers before any major component required service, 4 times the life expectancy of early model Panthers. Transmission efficiency was 20% higher. Fuel systems handled impurities without clogging. Cooling performance remained stable under conditions that would have crippled German engines. The more they tested, the more the pattern repeated. The Sherman performed consistently across every trial. The engineers began to see the broader picture. American design was not based on achieving perfection. It was based on ensuring function under all circumstances. The parts fit together not because they were crafted with microscopic precision, but because they were designed to tolerate imperfection. This principle, tolerance over precision, was alien to German industrial culture, yet it was proving decisive. In a long, classified memorandum, one senior engineer summarized it bluntly. This vehicle's greatest strength lies not in individual components, but in the philosophy of its construction. It forgives. That word, forgives, appeared repeatedly in subsequent reports. To German specialists trained to pursue flawless calibration, the concept was almost heretical. By late summer, the engineers' discomfort had deepened into respect. The Sherman's gearbox, its final drives, its engine, all were simple, reparable, and interchangeable. The field mechanics at Kummersdorf discovered that components from different manufacturers fit perfectly without adjustment. American companies, Ford, Buick, and Caterpillar, produced identical transmissions to shared specifications. German industry, by contrast, allowed small deviations between firms that made parts non-interchangeable. It was the difference between a machine built by craftsmen and one built by a system. Letters circulated among technical officers describing what they called die Amerikanische Einfachheit, the American simplicity. Some mocked it, others envied it. The more honest among them admitted that the simplicity concealed a sophistication Germany no longer possessed: the ability to build thousands of machines that behaved identically. As the summer of 1943 turned to autumn, field reports from the front reinforced the laboratory data. Captured Shermans in Italy were being tested under combat conditions by German units short of equipment. The results matched the Kummersdorf findings. These tanks required almost no mechanical support. They started in the morning, ran all day, and returned at night without failure. Mechanics who had spent years struggling with overheating Panthers and overburdened Tigers were astonished. For them, the enemy's tank had become an unlikely ally, proof that endurance mattered more than excellence. In Berlin, senior officers reviewed the cumulative reports in private. Few dared share them beyond trusted circles. The conclusions threatened to undermine the very foundation of German armored doctrine. For years, propaganda had celebrated the Tiger and Panther as symbols of invincible engineering. To admit that an American tank, designed by automotive workers in Detroit, could outperform them mechanically was politically dangerous. The findings were marked Geheim and stored under restricted access. Meanwhile, Kummersdorf continued expanding its trials. Engineers compared 3 Sherman variants, each with a different engine configuration: gasoline, diesel, and multibank. To their astonishment, all demonstrated the same underlying reliability. The diesel versions impressed even more, running cooler and consuming less fuel. In one report, a test officer observed that the diesel-powered model could travel over 3,000 kilometers without a major repair, triple the expected service life of a Panther engine. The differences in philosophy grew clearer with every test. The Germans built tanks as if they were watches, finely tuned, delicate, and demanding constant attention. The Americans built tanks as if they were trucks, durable, forgiving, and easy to repair. Each approach reflected its society. Germany trusted precision, America trusted production. Through the autumn months, the Shermans at Kummersdorf became silent teachers. Their disassembled parts lay across workbenches where German engineers studied them like relics of an unfamiliar faith. They realized that the Americans had optimized not for peak performance, but for availability, the ability to keep vehicles running in the mud, sand, and chaos of real war. To the engineers who had spent years perfecting theoretical specifications, it was a revelation and a humiliation. By December 1943, the evidence was overwhelming. Internal memoranda circulated with phrases like operational superiority through reliability and American industrial maturity as decisive factor. One report noted that Panther units in the field averaged less than 40% readiness, while American units equipped with Shermans regularly maintained above 80%. The data could no longer be denied. The conclusion was simple and devastating. Reliability was a weapon, and Germany did not possess it. The following winter, as snow blanketed the proving grounds, another Sherman arrived, this one captured from British forces in Italy. Engineers dismantled it and found the same consistent workmanship, the same forgiving design. They began to understand that this was not an exception, but a standard. American factories built machines that could be serviced by anyone with basic mechanical knowledge. Germany built machines that demanded experts who no longer existed in sufficient numbers. In field depots across Europe, German repair crews struggled to keep their Panthers moving. They fought not only the enemy, but their own machines. Transmissions failed. Final drives cracked. Engines burned out after a few hundred kilometers. Spare parts were scarce and often incompatible. Meanwhile, reports from units that had seized Shermans told another story. These captured vehicles, repainted with black crosses, simply kept going. The Wehrmacht's own mechanics wrote of them with reluctant admiration. One report from the Eastern Front recorded that American tanks captured from Soviet units required no modification before being used in German service. They functioned exactly as delivered. A Panther could be immobilized by a single broken sprocket tooth. A Sherman could run with half its track guards missing. As the year closed, the lessons gathered at Kummersdorf and across the battlefields began to converge. Germany had pursued perfection and achieved fragility. America had pursued function and achieved dominance. In the cold laboratories south of Berlin, surrounded by silence and secrecy, a handful of engineers realized that this single captured tank had exposed the true balance of industrial power. The war would not be decided by who built the most fearsome machine, but by who could build a machine that simply refused to stop working. Outside, snow fell over the proving ground. Inside, the American tank sat in a hangar, engine silent, hull streaked with oil and fingerprints. It had traveled from the deserts of Tunisia to the heart of Germany, not as a weapon, but as a messenger. Its message was clear. The future belonged not to those who built for brilliance, but to those who built for endurance. April 1944, Friedrichshafen, Germany. Night falls in a storm of light. 300 Royal Air Force bombers roar over the city, dropping waves of explosives that shatter the Maybach engine plant, and the ZF gearbox works beside it. Flames consume the factories that once built the heart of every German tank. Within hours, the Reich's ability to produce engines and transmissions collapses. The smoke rises higher than any flag, marking the slow end of an empire built on precision. While German workers dig through rubble, the assembly lines of Detroit run without interruption, stamping gears and forging crankshafts through every hour of the day. By the summer of 1944, the differences between the two nations' machines have become metaphors for the war itself. In Germany, tanks roll out of damaged factories already flawed. Components assembled by forced laborers often contain hidden sabotage. Sand in oil lines, cigarette filters and lubrication channels, bolts left deliberately loose. Engines seize before they reach the front. In America, music plays in bright, clean workshops as men and women work side by side, producing a new Sherman every hour. Where Germany's tanks are miracles of handcraft, America's are miracles of consistency. Reports from the field reach Berlin with growing urgency. Panther and Tiger units can no longer sustain movement over long distances. Final drives fail after 100 kilometers. Clutches burn. Gearboxes crack under the strain of their own weight. Some commanders begin to transport their tanks by train even within Germany, saving what mechanical life remains for the next battle. In many units, half the tanks never reach the front lines at all. In contrast, the Allied armies move relentlessly forward, their columns of Shermans covering hundreds of kilometers in a week. When one breaks down, spare parts are drawn from mountains of supply crates that follow every division. The design's interchangeability ensures that no tank stays dead for long. Mechanics replace an engine in hours, a transmission in a day. The Americans have built a war machine that repairs itself faster than the enemy can destroy it. At Kummersdorf, the last phase of testing on the captured Shermans continues even as the war begins to collapse around the engineers. By now, the data has turned into an indictment of their own system. Charts pinned to the walls tell the story in numbers. Mean time between failures, operational range, hours per overhaul. The Americans lead in every category. Every new test reinforces the same unyielding truth. In March 1944, General Heinz Guderian, the inspector of armored troops, receives a detailed assessment. It praises incremental improvements in the Panther's design, noting with pride that the average engine life has now reached 800 kilometers. The report describes this as acceptable reliability. At Kummersdorf, engineers reading the same report exchange quiet glances. The Sherman's engine, tested under identical conditions, surpasses 3,000 kilometers. What Germany calls success, America achieved from the start. The pattern repeats across every system. The Sherman's transmission remains smooth and silent after weeks of operation. Panther drivers, forbidden to shift too often, learn to skip gears to avoid breakage. The Sherman's final drives remain intact under heavy stress. German crews abandon vehicles with shattered housings and stripped gears. Every statistic, every experiment, every field account points in the same direction. Reliability is not an accident, it is a culture. As Allied forces prepare to invade France, German engineers understand that their enemy's advantage is not simply quantity, but dependability. A tank that moves when ordered is a soldier in itself. A tank that breaks is dead weight. The mathematics of warfare, once hidden behind rhetoric, become painfully simple. A Panther may destroy one Sherman in battle, but 5 Shermans will arrive while 3 Panthers remain in repair. By autumn, captured Shermans serve quietly within German formations as substitutes for their own crippled machines. Mechanics who once cursed American engineering now depend on it. They repaint the tanks, remark the instruments, and drive them into combat. Letters from the front describe the same astonishment found at Kummersdorf. It starts every time, one soldier writes. It runs even when abused. We wish our own machines behaved this way. When the Allied invasion begins in June 1944, these words become prophecy. Across the hedgerows of Normandy, American tank battalions fight continuously for weeks. Shermans burn, but they return, replaced by others built overnight. For every tank destroyed, 2 more arrive by ship. Behind them stretches a continent of factories untouched by war. Behind Germany stretches ruin. Inside Berlin, the last meetings of the Armament Commission grow tense. Reports pile on Speer's desk, filled with bad news cloaked in technical language. Production quotas unmet. Quality declining. Fuel shortages worsening. The engineers still working at Kummersdorf know the truth better than anyone. They have measured it, recorded it, watched it unfold with mathematical precision. The war has already been lost on paper. In January 1945, a final summary circulates among Armored Command. It lists the number of defective final drives reported across the major tank models. The numbers are staggering: 500 failures in the Panzer IV, 370 in the Panther, nearly 100 in the Tiger. Even the light vehicles, once considered dependable, are breaking down faster than they can be repaired. The report ends with a statement from General Wolfgang Thomel, Chief of Staff under Guderian. Orderly utilization of tanks is no longer possible. The troops have lost confidence in their vehicles. Those words mark the death of German armored warfare. A tank division without faith in its machines is no longer a fighting force. It is a burden. Soldiers begin abandoning vehicles at the first sign of trouble, leaving them by the roadside to be captured intact. In their place, American-built tanks roll on, each a testament to an industrial philosophy that Germany failed to understand until too late. As Soviet artillery nears Berlin, the engineers at Kummersdorf receive orders to evacuate. They crate their documents, their measurements, and their shame. Some of the captured tanks, including the Shermans, are pressed into last-ditch defense units. They fight side by side with the Panthers and Tigers that once symbolized German pride. In those final chaotic battles, the comparison plays out one last time. The Shermans continue to run until they are hit or run out of fuel. The German tanks fail from within. Their engines overheat, transmissions seize, and crews are forced to flee. When the war ends, the proving ground falls silent. Among the wreckage, War Daddy 2 lies half-buried in the sand of a bomb crater, its hull scorched but intact. Around it are the shattered remains of the machines that were supposed to surpass it. The engineers who survived the collapse of the Reich carry with them the memory of a single foreign tank that humbled their craft. In its simplicity, they saw the future. In the years that follow, as West Germany rebuilds its military under NATO supervision, that lesson shapes a new generation of designers. The Leopard 1 tank, conceived in the 1950s, embodies the opposite of the wartime philosophy. Its designers favor reliability over complexity, accessibility over mystique. Its engine can be removed in 20 minutes. Its transmission is modular. Its systems are standardized. Beneath the surface lies the unspoken legacy of Kummersdorf, the acknowledgement that reliability is the true measure of engineering strength. Historians later study the German test reports that survived the destruction. They read the tables of numbers, the temperature graphs, the wear analyses, and the understated comments scrawled in the margins. Each entry, each observation, each reluctant admission tells the same story. The captured Sherman did more than perform. It revealed a civilization built around function, adaptability, and faith in its workers. For Germany, the war had begun with the belief that superior design could overcome inferior numbers. It ended with the realization that industrial maturity decides the outcome of modern conflict. The American engineers who built the Sherman understood something that their adversaries did not. A weapon's greatness lies not in its complexity, but in its consistency. A machine that functions every time will always defeat one that functions occasionally. By the end of the war, the United States had built more than 49,000 Shermans, each one a rolling equation in steel, proving that volume and reliability together form a power greater than innovation alone. Germany, for all its brilliance, could not match that scale or that certainty. The proof lay in every field report, every abandoned Panther, every burned-out Tiger. The weapon that works is the weapon that wins. In the quiet years after the war, when surviving German engineers looked back on their notebooks from 1943, they found themselves haunted by the data they had recorded. They had known the truth even then. The numbers did not lie. The Americans had built tanks for soldiers. They had built tanks for perfection. The Americans designed for movement. They designed for control. In the end, it was movement that mattered. The story of the Sherman at Kummersdorf became a parable told in whispers, a story of humility learned too late. It spoke not of defeat in battle, but of defeat in mindset. The tank that Germany captured to study had become a mirror reflecting its own failures. Through that mirror, the future of engineering was rewritten. Today, the lessons endure. Every machine built to serve must first endure to serve. Every weapon that claims superiority must prove it through reliability. The desert tank that crossed 300 kilometers without complaint, that endured every test a rival nation could devise, that forced its captors to rethink what strength meant. That machine carried more than steel within its hull. It carried an idea. That idea was simple. In war, as in life, perfection dies when it cannot last. Reliability endures. And sometimes, the most ordinary machine becomes extraordinary simply because it never stops working.